Hi, I'm Amy at the Alti store. We sell a lot of solar panels for DIY off-grid solar projects. Generally, when we design a solar system, we start with your loads. What are you trying to power? And from there, you figure out what size solar panel you need. We've got lots of videos walking you through those calculations. But now, we're going to look at it the other way around. What can you power with a 100-watt solar panel? A solar panel is rated by the amount of power it creates at standard test conditions, or STC. These conditions include the intensity of the sun, 1,000 watts per square meter, the angle of the light hitting the panel directly, the temperature, 25 degrees Celsius or 77 degrees Fahrenheit, and other criteria. So as they say, actual mileage may vary based on all of these factors in the real world. So we reduce the calculations based on the difference between the lab setting and your actual installation. When a 12-volt solar panel is rated at 100 watts, that's an instantaneous rating. If all the test conditions are met, when you measure the output, the voltage will be about 18 volts and the current will be about 5.55 amps. Since watts equals volts times amps, 18 volts times 5.55 amps equals 100 watts. Watts is like the speed of a car, miles per hour. How fast is it going at that instant? 50 miles per hour. To figure out how much power is generated over a period of time, you multiply the watts times the number of hours it's running. So in 1 hour, 100 watts times 1 hour generates 100 watt hours. Again with your car, 50 miles per hour times 1 hour equals you've gone 50 miles. Now that we know the math behind it, we need to figure out how many hours to plug into the equation to determine how much power the solar panel will generate in a day. How many hours of sunlight that is equal to the intensity of the standard test conditions, which is basically the sun at noon, will the solar panel be exposed to during the day? The number of hours of sunlight equal to noon is called sun hours. As you well know, even though the sun is up at 8 in the morning, it's not as bright as it is at noon. So you can't just say that the sun is shining for 10 hours, so I'll multiply 100 watts times 10 hours. The hour between 8 and 9 in the morning is probably only half as strong as the hour between noon and 1 in the afternoon. So the morning hour would probably only be equal to about a half a sun hour. Also, the days are so much shorter in the winter than the summer, the number of sun hours would be dramatically different throughout the year. And the amount of sunlight I'd get in Miami, Florida would be different from the amount of sun I'd get in Portland, Maine. Okay, this can get complicated. Luckily, some very smart people have taken decades worth of weather data and calculated out the number of sun hours for all over the world, broken out by month, and even the tilt angle that the panels are mounted. So I can look at the charts to see if I have a solar panel in Portland, Maine, installed at 45-degree angle. On an annual average, I get 4.6 sun hours a day. Likewise, if I took that same solar panel in Miami, Florida, installed it at a 25-degree tilt, I'd have an annual average of 5.2 sun hours. Just as a little aside, I want to make sure you see that during the months of June and July, I'm going to get more power out of that solar panel in Maine than I will in Florida. With Florida being closer to the equator and Maine being closer to the North Pole, the days are longer in the summer in Maine, and so the sun shines on the solar panels longer. Kind of cool, huh? Okay, back to the question at hand. What can I power with a 100-watt solar panel? I need to figure out my worst case scenario. What's the worst performing month that I'll be using the solar panel? Since for this example, I'm going to be using it in Maine, during ski season, I need to figure on December. So how can I squeeze out as much power as I possibly can in December? By tilting the solar panel steeper so it points right at the low winter sun. So I'm going to mount my 100-watt solar panel at 60 degrees and figure on 3.2 sun hours. I will now take 100 watts times 3.2 sun hours and get 320 watt hours a day in December. Now, as you know, nothing in real life is perfect, so I have to figure in losses that I'll likely incur, such as voltage drop across the wire, dirt or snow accumulating on the solar panel, losses through the charge controller, etc. So I'm going to multiply that 320 watt-hours times 0.7. I know. That's figuring on losing about a third of your power. Reality's a bummer. So I now end up with 224 watt-hours of power that I have made with my 100-watt solar panel on a December day in Maine. So what can I do with that power? Well, first, I need to store it in a battery so that I can use it later when I need it. So I'm going to use at least a 7-amp charge controller to manage putting the power into a deep cycle battery that can be charged and discharged on a regular basis. So what size battery do I need? Sorry, that calls for more math. I have my 224 watt-hours that I'm making, and I'm putting it into a 12-volt battery. Because watts divided by volts equals amps, 224 watt-hours divided by 12 volts equals 18.6 amp-hours. Even though I'm putting it into a deep cycle battery, most batteries don't like to be drained down more than halfway. So I'm going to make sure I get a battery that can hold at least twice as much power as I'll be using. So I'll only use half of the power in it. 18.6 amp-hours times 2 equals 37.2 amp-hours. The amount of power that a battery can store changes depending on the temperature of the room it's in. If my battery is going to be as cold as 60 degrees Fahrenheit, I need to increase the size of the battery by 11% to accommodate the cooler temps. 37.2 amp-hours times 1.11 equals 41.3 amp-hours. I'm also going to be converting the DC power from my battery to AC using an inverter. And I'm going to lose about 5% of my power through that conversion. So 41.3 amp-hours divided by 0.95 equals 43.4 amp-hours. Now, I don't know if you've ever been to Maine in the winter, but trust me on this one. The sun doesn't shine every day there in December. Not by a long shot. So I need to figure out how many days without sun that I need to store the power for me to get through those sunless days. Let's say I need it to last me through the weekend without sun. 43.4 amp-hours times 2 days equals 86.9 amp-hours. Great. I'm going to get myself a Group 27 deep cycle battery. That's 89 amp-hours, 12 volts. Okay, now I can finally figure out what I can do with that power. I can run my laptop that uses 45 watts for 5 hours. Because 224 watt-hours divided by 45 watts equals 4.97 hours. Or I can power 3 of my 10-watt LED lights for 7 hours and still have a little power left over. Or I could make myself a cup of coffee, listen to the radio while reading a book with a 10-watt light on for 3 hours, and use my laptop for 2 hours. This should give you enough information so that you can figure out how to fit this into your situation. You can change the numbers to fit your area and your power needs. If you need a little help, you can go to our loads list calculator to see how much power common appliances use, and go to our reference page to see some sun hour charts and maps. If you enjoyed this video, give us a like and a share, and subscribe to our Alti Store channel to be notified when we post more videos. Also go to our website at altistore.com, where we've been making renewable doable since 1999.